Hi, this is Arnav. Welcome to the channel. Today I have Rajarshi with me again, and we are going to talk about Hashgraph. So Rajarshi is the main content writer for Blog Geeks and a cryptocurrency researcher for Springroll and cryptocurrency news reporter for CoinLife. And he has been on the channel three times before as well. And he is again here to talk about Hashgraph. So hi Rajarshi, how are you, man?
I'm good. I'm good. Glad to be back here again, making
Great.
a habit of it, but it's pretty awesome.
Yeah. So yeah, let's begin, man. So can you talk about what is Hashgraph?
So, Hashgraph is this consensus mechanism created by this guy called Lehman Baird for this company called Swords. Now, Hashgraph came about because I think you and I will both agree with the fact that blockchain is one of the greatest innovations of all time, correct?
Yes.
But it also has its limitations. For example, it's not the most scalable of system. Like we both know the scalability woes of the cryptocurrencies and what they're going through. Like Bitcoin can only do 7 transactions and Ethereum is struggling with 15 to 20. Those are very real problems. And secondly, they're not the most fair of system. Like it's not a first come, first serve kind of a system. So to solve these problems, Hashgraph came about.
Got it. Okay. So can you talk about more details? Why was it required? Like maybe some examples and yeah.
Sure. So before I continue, there is one distinction that you need to make. Hashgraph is a voting system. That is how they're positioning themselves, and that is how they want to be perceived. So, how is a voting system different from, say, proof of stake or proof of work? What happens in a proof of work? A lot of miners come, they spend their computational resources to find and mine for a block. Somebody gets lucky and that block gets added to the blockchain, right?
Yep.
Proof of stake, what happens? There are a lot of validators who put up a stake in the system. Then they bet on a particular block. And if somebody does not bet on the correct block and acts maliciously, he or she gets punished. And that validated block gets added to the blockchain. That is proof of stake. The problem with both of them is that, as I said, they're not a scalable system because when you when a miner mines a block in a say in a proof of work protocol or even in a proof of stake protocol, that block needs to propagate through the entire system and all the nodes need to come to a consensus, say that yes, this is the right block and this goes in the blockchain. Now, this propagation itself takes a lot of time. And the second problem that we, as I mentioned before, is that they're not a very fair system. For example, if I send you like 1 or 2 Bitcoin, right? My transaction thing will be added to the mempool with like hundreds of more transactions. And there was a study that came out that said that if I pay the minimum transaction fees, then I might have to wait till 29 minutes to get my transaction through, which is a joke for a payment system that is for Bitcoin specifically.
Yeah.
So this we needed something that was more fair and that was more scalable, and that is what Hashgraph promises. They are promising 250,000 transactions per second, like compare that to 7 and 15, right?
Yeah. Yeah.
And they're promising an extremely fair system which is Byzantine fault tolerant, and that is basically the advantages that they have over that.
Got it. Got it. 250,000 is really a big number. I think even Visa does like
It's
70
huge.
thousand per second.
Yeah, something like that. It's just insane. If they pull it off, then it will be pretty amazing.
Yeah. Okay. So, can you talk about some more deep dive into the technical aspects, like how does the virtual voting and the gossip protocol work in the whole consensus system? I know this topic would require a lot of visuals, and I would request the audience to check out Raj's article because it has all the visuals and examples corresponding to that. Yeah. So, can you talk more about these?
Yeah, I agree with you. Like it is. I agree with you because, like, see, it's impossible to explain the virtual voting and the gossip about gossip protocol without the visual cues. I'll try my best, but I do recommend the audience to like check out my article while I'm still talking about it. So, the entire consensus system in a hash graph can be divided into gossip about gossip and virtual voting. So, what is gossip about gossip and why was it required? If you check out a normal voting system, right, any normal voting system, how does it work? Suppose there are three nodes, Alice, Bob, and Charlie. These three people just talk among each other. They come to a decision, and then they decide on whatever the outcome is. Now, this is not practical for a large scale system, because imagine thousands and millions of nodes talking to each other constantly and coming to a decision. There's no system in the world that has so much bandwidth to handle that much data. So we needed something which can make the system scalable and fast. And that is where both these protocols come in. First and foremost, what is the gossip protocol? We know the gossip system, right? It is a very old and tried and tested protocol in network systems. So in a gossip about gossip protocol, suppose there are 4 or 5 nodes like Alice, Bob, Charlie, David, Eric, right? So how will it work? Suppose Alice knows something. She will randomly choose one of these people and tell them that information. Suppose she said that to Charlie. Now Charlie will randomly tell to Bob. And what Charlie will tell Bob is not only the new information that he's telling him, but he will also tell him the information that Alice told him. Every piece of information that that person knows will be told to their immediate neighbor, and that is how the message gets propagated. So in a hash graph, suppose node A that node A wants to gossip with node C, then they will create this new event. This event has the hash of node A, hash of node C, the information, and the timestamp. The timestamp is also very important because, as we'll later on find out, it helps with the fairness of the system. The timestamp, the data, and the 2 hashes. This thing is called an event. So suppose now C wants to gossip with node B. They will create another event which will have all the data that C wants to tell B along with all the data that A told C. So I know it's very complicated without the diagrams thing, but let me just explain it with another example. Suppose I have a friend like Akshay, and then there's other friend Jack, right? And I am talking to Jack, and I say that, Jack, I really, really love Pink Floyd. Fine. Okay. Jack then goes to Akshay and says, hey Akshay, I really love Metallica, but did you know Raj also loves Pink Floyd? So he's not only telling him what he likes, he's telling him what I like as well. So then Akshay will say, suppose go and tell Rita that, I love Iron Maiden, Jack loves Metallica, and Raj loves Pink Floyd. So you see how this network is getting the information. Like, I just told what they call, I forgot the name, but yeah, whatever. I told somebody that I like Pink Floyd, right? But now this person, Rita, knows what I like without me directly telling her what I like. You see how the network is getting propagated here? That is the beauty of gossip about gossip. Like I didn't even need to directly tell them. Like, they just knew because somebody else told them that I liked something. That is gossip about gossip. Now, when it comes to virtual voting, that is the second part of this thing. Now, once again, I want to reiterate what we just said before. Like, it requires a lot of visual cues. Please go through my article if you want a detailed viewpoint. But I'll just tell you the mechanism and the philosophy behind virtual voting. So, virtual voting basically means that entire network system coming to a decision without each node knowing what the other node is voting for. Let me repeat that. Without each node knowing what the other nodes are voting for. Now, how does this work? For example, let's say let's do an election, right? Let's say that
So
we are choosing
what are they voting for? Like what are the decisions that they're voting for? What the transactions that are taking place in the network?
Yeah, that I was getting to that. So for example, they're voting for transaction validation, or for, say, like any decision that the network wants to make governance wise or something like that. These are the decisions that they're making, right? So in a virtual voting, what is happening is that they're voting and coming to a decision without each node knowing what the other node is voting for. How does that work? Because of gossip about gossip, because each node knows what that other person is thinking and that other person is talking about. For example, like I said, let's do an election. Let's choose between, say, Ajay and Vijay, right? Now, I tell you all these things about Vijay, that I think that Vijay is amazing, Vijay is a great guy, Vijay is brilliant. You know all this information about what I am thinking about this particular person. So when election comes, you don't even need to ask me who I'm voting for, right? You already know that I'm voting for Vijay without me explicitly saying it to you, because you know about all these things that I've said about Vijay. That, in a way, is a layman's term of saying how this virtual voting works. I don't need to explicitly tell you that I am in and I'm like validating this transaction, but because through gossip about gossip, I've already given you all this information that I have. You know what my decision is going to be. That is virtual voting. You knowing what I'm going to vote and me knowing what you are going to vote without us explicitly saying it to one another.
Okay. So how does it work technically? Like for transactions, say you got information that Ajay transferred something to Vijay, Vijay transferred something to
Hmm.
Akshay, and finally,
Hmm.
say Raghav told you all this information. So
Huh.
how does it like work? How do you interpret that? You add it somewhere. How does it get stored? How do you see like what are the transactions that took place?
See, for example, for this transaction thing, I'm again saying that we need the visual cues, because what is happening is that the entire hash graph this gets divided into certain periods, and each period has a particular node, and they all vote for a popular node, so to speak. And it's a very complicated process that cannot be explained verbally, but just the idea behind it is that if suppose Raghav is sending certain amount of money to, say, Ajay, right? And I am saying that to you, that I know that this transaction happened. And then you are talking to somebody else, then you're saying that you also know that transaction happened. And you also know that I told you that this transaction happened. So
Okay.
that is how that message is getting propagated. Like everybody knows what everybody else is thinking and saying. Think of a hive mentality, right? Hashgraph virtual voting is basically a hive mentality. Since everybody is gossiping with everybody knows what everybody is talking about and what everybody thinks.
Got it.
That is the philosophy. And once the moment two-third of the people agree about a particular like come to a consensus about a particular transaction, it goes through. They
Oh,
don't have to wait in the main pool. They don't have to wait for anything. The moment it reaches two-third, it goes through, and that is where the fairness of the system comes in. You don't need to wait in the mempool for like 25-29 minutes so that somebody can send somebody like one Bitcoin. Like, it's just first come first serve, plain and simple.
okay, okay. So, like, there are how much is the transaction time and cost in the Hashgraph system?
That they haven't explicitly mentioned yet, because they haven't done any real life study yet. As of right now, it's just a concept, and like they have not really like done it in a public way, because that is what I was going to come to next. That Hashgraph until now is only like a private system. It has not been like tested out in a public non-permission system, so to speak. It is
Okay,
still very private, and it is very like closed, and at the same time it is not an open source system like most of these other blockchains and cryptocurrencies are. It is
okay,
very much a patented system, and if you want to use it, you need to take Swell's permission to do it.
got it. Okay, so that is like some negative points that are associated with
Yeah, that is definitely some negative points. Like, while it is true that the transaction speed that they're talking about and the fairness of the system are very like alluring properties, so to speak. But I mean, like as of right now, it's just talk. I mean, like obviously they have done some testing and all, but unless and until it is proven in a public space, we cannot really say whether it can be the blockchain killer, the so to speak.
Got it. Got it. Okay. Okay. Thanks a lot, Raj, for your insights, and thanks a lot for coming on the channel again. I would request our audience to check out Raj's article. The article has a lot of great images and examples, and it would increase your knowledge base of Hashgraph even more. So yeah, thanks a lot, Raj. Okay. Bye bye.
Bye.